Section here in chapter 5 contains our half angle identities, and just reading through these or looking down through, you can see we have 5 versions, one for cosine, one for sine, and 3 different ones for tangent. Much like we talked about with our double angle identities, when you have 3 versions here, you can choose to use whichever one you would like. Some instances it does make a difference, others when you just calculate a value it really does not. So we have start over here with tangent, or the cosine, sorry. Cosine of a divided by 2 is plus or minus the square root of 1 plus the cosine of a divided by 2 during the entire fractions underneath the radical, which creates some simplifying issues for us. Sine of a over 2 plus or minus 1 minus cosine a over 2. And then as I mentioned, the 3 versions for tangent. Tangent is sine over cosine, so 1 minus cosine over 1 plus cosine. Or we have another version, sine of a over 1 plus cosine of a, or 1 minus cosine of a over sine of a. Again, any one of these 3 can be used depending on our specific situation. But let's go ahead and apply those here. We're going to use our half angle identities to find the cosine of 15 degrees. Well, cosine of 15 degrees from a half angle is 30 divided by 2. So in other words, right now, our A value is 30 degrees. So I'm going to substitute that into our cosine value right here, and we have plus or minus the square root of 1 plus the cosine of 30 degrees divided by 2. I'm going to start right away with this plus or minus. This one is fairly simple because 15 degrees is going to be in the first quadrant. Everything is positive in the first quadrant, so from here on out, I'm just going to leave the plus or minus off of there because it will be a positive value for our radical. From here, I'm going to substitute what I know. Cosine of 30 is square root of 3 over 2 and being divided by 2. I'm going to step down here to simplify, so still underneath my radical. I want to take these 2 terms that I have up here in the numerator and make those a single fraction. That way I can simplify my complex fraction. So that's 2 plus the square root of 3 over 2, and noting that's still being divided by this 2 here. Again, all underneath that same radical. So underneath that radical, I have 2 plus the square root of 3 divided by 2. Since I'm dividing by this 2, I'm going to multiply by the reciprocal, which is 1/2, which gets me 2 plus the square root of 3 all over 4. And now we have a little bit of simplifying we can do. I'm going to write those as separate radicals, 2 plus the square root of 3 over the square root of 4, because we all should know that the square root of 4 can simplify down to 2. So there is our exact version of the cosine of 15 degrees by using our half angle. Much like we've done with the previous ones, we use the actual identity itself, plug in the values, and then we simplify with what we can do. Notice number 2 is a tangent of 22.5. So I'm going to assume, once again, that we all, using our half angles, would know that we do 45 divided by 2 to get 22.5, which means that, oops, let's try that again, the A is actually 45 in this case. I'm going to scroll back up here because I mentioned we can use any one of these 3 forms here. Let's just go ahead and let's use the bottom one here. And we have 1 minus cosine. I'll go ahead and write it over here. 1 minus cosine divided by sine. In this case, A is our 45 degrees, so 1 minus the cosine of 45 degrees divided by the sine of 45 degrees. I'll slide down here and make our substitutions. The cosine of 45 degrees is square root of 2 over 2. The sine of 45 degrees is also square root of 2 over 2. I'm going to make this one fraction. So I have 2 minus the square root of 2 over 2 over square root of 2 over 2 over 2. And we'll go ahead and multiply by the reciprocal of 2 over the square root of 2. Cross canceling, these 2's, which ultimately gets me 2 minus the square root of 2 all over the square root of 2. We can't have a radical in the denominator, so we have to rationalize by multiplying numerator and denominator by the square root of 2. I'm going to have to slide down to the next line to do that. In my denominator, square root of 2 times the square root of 2 is just 2. In my numerator, 2 times square root of 2 is just that, 2 square root of 2. My numerator, square root of 2 times square root of 2 is square root of 4, or 2. You should then notice that those all can be divided through by this 2, or gives us square root of 2 minus 1 for our tangent of 22.5 degrees. There's a quick introduction to each of those two, sine or cosine and tangent. Let's see what's next here. Given that the cosine of s equals 2/3 and s is between 3 pi over 2 and 2 pi, which puts us in quadrant 3, find sine of s over 2, cosine of s over 2, and the tangent of s over 2. Well, we'll start with the sine of s over 2. I'm going to scroll back just so we can look at this identity. It's plus or minus the square root of 1 minus cosine divided by 2. So we go forward. I have plus or minus the square root of 1 minus the cosine divided by 2. Maybe I should replace that a with an s, different variables as we go through here. So we already know the cosine, so I have plus or minus 1 minus 2/3 divided by 2. Hoping we all know 1 minus 2/3 is 1/3 divided by 2. 1/3 divided by 2 is 1/3 multiplied by the reciprocal, which gets us plus or minus the square root of 1/6. I'm going to keep my simplifying going on here, plus or minus the square root of 1 over the square root of 6, which is plus or minus 1 over the square root of 6. We'll rationalize by multiplying by square root of 6, and I have plus or minus 1 times square root of 6 over 6. If we go up here, it tells me that S is in quadrant number 3 between 2. I messed that one up. We're not in quadrant 3, we're in quadrant 4. I didn't read that carefully enough. Quadrant 4 between 270 and 360. Okay, so S over 2 would be between 135, half of 270, and 180, which would put us in quadrant number 2. We're working with the sine here. Sine, as we all know, is positive in quadrant 2, so our sine is a positive square root of 6 over 6. From here, we'll go ahead and move on to find the cosine of s over 2, which is plus or minus, and just so we can see it again, I'm going to scroll back again, plus or minus 1 plus the cosine of a divided by 2. So 1 plus the cosine of s divided by 2, or plus or minus 1 plus 2/3 divided by 2. In this case, plus or minus 1 plus 2/3 is 5/3 divided by 2, or 5/3 times a half. So we have plus or minus the square root of 5 over 6. We'll do some more simplifying here. Plus or minus the square root of 5 over the square root of 6. We'll rationalize by multiplying by square root of 6. I have plus or minus the square root of 30 over 6. And cosine, we just said that s over 2 is in quadrant number 2. Cosine is negative in quadrant 2, so our cosine is negative square root of 30 over 6. Now we can go ahead and go through the same thing for tangent here, but as we've discovered through our work, tangent is sine over cosine. And since I've already solved for those, sine is square root of 6 over 6, cosine is negative square root of 30 over 6. I can simplify that and have square root of 6 over 6 times 6 over negative square root of 30. The 6's will cancel. And I need a little bit more space here, so I'm going to scroll down just a little bit. I actually have the square root of 6 over negative square root of 30 right now, or they can because both underneath the radical they can simplify. So I have the square root of 1 over the square root of 5, or eventually negative square root of 5 over 5 for our tangent. Okay, so that's going through an example of each one. Let's go ahead and continue on and apply a little bit more. Simplify the expression using our half angles. So you'll notice this looks an awful lot like this version, 1 plus the cosine of A divided by 2, which is our cosine of A divided by 2. So by a period of substitutions, our A is going to be 12x. So I have plus or minus the square root of 1 plus the cosine. Oops, I have that already. I'll just rewrite it, I guess, since I started. 12x divided by 2 that matches up directly with this. So I'm going to go to this form. I have the cosine of 12x divided by 2, or the cosine of 6x. So all we've done there is work backwards from our expanded version or identity back to its half angle, which is the cosine of A divided by 2, or in this case 12x divided by 2, or the cosine of 6x. This one here, 1 minus the cosine of 5a, or 5 theta, over the sine of 5 theta, looks like 1 minus the cosine of A divided by the sine of A, which is the tangent of A divided by 2. So notice that these two match up, which essentially means that A is 5 theta. So over here I have the tangent of 5 theta divided by 2. Really can't do much else with that, so that is our version here. And do we have one more? No, we have an identity. So sine of x over 2 plus cosine of x over 2 squared equals 1 plus sine. Squared means to take that expression and multiply it by itself. So I have sine x over 2 plus cosine x over 2 being multiplied by itself, which means I will FOIL. And if I FOIL, first term sine times sine is sine squared. Outer terms sine x over 2 times cosine x over 2. Inner terms would also be cosine x over 2 sine x over 2. And our last terms, cosine times cosine is cosine squared of x over 2. Going a step or two further, I'm going to show it here as sine squared of x over 2. Rearranging, I'm going to put the cosine squared with it. So I just move this term to the front. And then these two are the same, so I have 2 of those. From our previous work way back in our first or second section, sine squared plus cosine squared equals 1, regardless of what the angle is. This is the same thing as our double angle. Remember 2 sine A cosine A, which in that case is the sine of 2a. In this case, a just happens to be x over 2, so I have the sine of 2 times x over 2, or 1 plus the sine of x, because the 2's will cancel here, and we've proved our identity right here. And there would be a quick look at our half angle identities for sine, cosine, and tangent.